You've heard me say these terms several times now, and it's finally actually properly defined them, the sidereal and the synodic periods. So the sidereal period, that's the time for, say, a planet to go once around the sun. And that's it. Earth, obviously, it's 1 year. And for the other planets, it'll vary depending on how far away from the sun they are. The further away you are, the longer it takes, the greater your sidereal period is. So the sidereal period's easy to comprehend. It's the time around. The shortcut I always like to use and repeat is that it's the, quote, real period, that time to orbit the sun. Now, what about this synodic period? Here's that fancy definition. It is the time for the planets to be in opposition again. In essence, we're going to say it's sun, earth, planet. And wait some time, all right? You let the earth orbit, you let the planet start to orbit, and the next time that they're in opposition again, sun, earth, planet. When that opposition occurs again, that will be the synodic period. So remember, Earth is orbiting around, and it's going a lot faster around the sun than, in this case, this superior planet. And you're looking for the time for them to be lined up. And once they're lined up again, that'll be your synodic period. So what's the advantage of defining this weird time for things to sync up again? Well, Copernicus showed that, hey, if you take the synodic period, which I'm going to label with an S, versus the sidereal period, the time to orbit the sun with a capital P, you can relate that to Earth's sidereal period, Earth's orbit around the sun. 1 year, 365.26 days. 2.5, you're being shorthand and lazy. All right? What Copernicus showed is, hey, for inferior and superior planets, there is this nice formula. The only difference between these two is the plus or minus sign. Plus for inferior, minus for superior. These are geometric arguments that I'm not going to go into detail. But what matters here is that, hey, if you know Earth's period around the sun, 1 year, and you measure the synodic period, the time for Earth and said planet to come into opposition again, you've gotten the sidereal period. You can calculate the sidereal period. So you don't have to wait literally decades in some cases for a planet to orbit the sun once. You just need to wait for Earth and that planet to be lined up again. You measure the synodic periods. This is what we physically measure here on Earth. And once you have that synodic period, you get the sidereal period, how long it takes the planet to orbit the sun. And that's the power of these tools. Now we have these new powerful tools. Let's go ahead and put them into use. Let's try and calculate the sidereal period of Saturn. So as a reminder, Saturn will have a synodic period of 378 days, a little more than a year. And the synodic period is that time for Saturn and Earth to be in opposition, all lined up straight with the sun. Right? So since Saturn is a superior planet, we're going to use the minus equation, and we need to calculate Saturn's sidereal period. E will be Earth's period, 1 year, and S will be Saturn's synodic period, that time to be in opposition. So we need to get P up into the numerator, but I have a problem of different denominators. So what I'm going to do is multiply the 1 over E by an S over S. And then the 1 over S by a E over E. All right? I'm multiplying by 1 in a fanciful way so that I can get a common denominator on both terms. So now we can see that common denominator, SE or ES, order doesn't matter. Combine them, and we'll just be left with this S minus E term, which means now we're free to just flip the equation around. Flip this one over, get P in the numerator. Correspondingly, flip these guys over. So we'll do this. Jump to our newest equation, where we can now say that the sidereal period of Saturn is the product of synodic period, Earth's sidereal period, synodic period of Saturn minus Earth's sidereal period. So if you're having trouble keeping up with the terms here, let's just plug in the numbers so we actually have some sort of context. Some sort of cue here, where Saturn's synodic period, the time to come into opposition, multiplied by Earth's period, 1 year, divided by the difference of the two. And you put it on a calculator, and you'll find that Saturn orbits the Sun about every 30 years. About every 30 years. Amen. That's the power of Copernicus' tools. We only need to wait for oppositions, the synodic period, to happen. And with that information, we've calculated the sidereal periods, the time it takes for Saturn to have one orbit around the Sun. As a reminder, Copernicus did not invent heliocentrism, but he was able to order the planets. He figured out the positions of the planets relative to the Sun, and he calculated the time for them to orbit. He calculated their sidereal periods by measuring synodic periods, the times of oppositions. And Copernicus was able to eliminate the epicycles that Ptolemy had come up with so many millennia ago. And this is another example of using Occam's razor. That idea that we need to reduce the number of assumptions. Epicycles has those crazy orbits stacked on top of orbits, whereas once you switch to a heliocentric model, you just need to say, hey, Earth is moving around the Sun. Earth is another planet. Think about that. Before, Earth wasn't a planet. Earth was the special center of the universe because we were there. But if you accept heliocentrism, you make Earth a planet, and everyone orbits around the Sun, and you can explain the retrograde motion of the planets now.